Welcome to the course on software modeling. In this course, we will learn about the process of modeling software, categories of software models, qualities of software models. A software model is a representation of real-world objects and their relationships, focusing on essential items. It helps in understanding the problems involved in building something and can be used as a means of communication between stakeholders and users. In software development, it's important to have a structured and well-defined process in place to ensure that the software product meets the requirements of the stakeholders. Software modeling is an integral part of this process, and it involves creating a representation of the software system that accurately depicts its functionality, behavior, and structure. The software modeling process consists of several stages, and the first stage is the description of the problem. This involves identifying and defining the problem that the software product is intended to solve. This stage is critical as it lays the foundation for the entire software development process. After the problem has been described, the next stage is the analysis of the problem. This involves gathering information about the problem, identifying the stakeholders, and defining their requirements. This stage is important because it ensures that the software product meets the needs of all stakeholders. Once the problem has been analyzed, the next stage is the proposition of a solution. This involves identifying potential solutions to the problem and evaluating them based on their feasibility, cost-effectiveness, and ability to meet the stakeholders' requirements. The solution proposal should be well documented and should outline the steps that will be taken to develop the software product. The next stage is the design, implementation, and deployment of the software product. This stage involves creating a detailed plan for the software product's development, including the software architecture, design patterns, coding standards, and testing procedures. This stage is critical as it ensures that the software product is developed to the highest possible standards. Finally, diagrams are used to specify how the finished software product should look and act. These diagrams are created based on the software modeling process and are used to provide a visual representation of the software product's functionality and structure. They help developers and stakeholders to understand the software product's design and behavior, which in turn ensures that the software product meets the stakeholders' requirements. In summary, the software modeling process involves the description of a problem, analysis of the problem, proposition of a solution, design, implementation, and deployment of the software product, and the creation of diagrams to specify the software product's functionality and structure. By following this structured process, developers can create high-quality software products that meet the needs of all stakeholders. Categories of software models, which are static models and dynamic models. Static models are used to describe the structure of a software system. They represent a set of elements and the relationships that exist between them. Some examples of static models include class diagrams, object diagrams, component diagrams, and deployment diagrams. Class diagrams show the classes and their relationships in a system. Object diagrams represent instances of classes at a specific point in time. Component diagrams depict the components of a system and how they interact, and deployment diagrams illustrate the physical deployment of software components on hardware. On the other hand, dynamic models are used to describe the behavior of a software system over time. They represent how the software system functions and its interactions. Examples of dynamic models include use case diagrams, sequence diagrams, collaboration diagrams, state chart diagrams, and activity diagrams. Use case diagrams depict the interactions between actors and use cases in a system. Sequence diagrams show the sequence of messages exchanged between objects. Collaboration diagrams illustrate the interactions between objects. State chart diagrams represent the different states an object can be in and how it transitions between states, and activity diagrams depict the flow of activities and actions in a system. Static models and dynamic models are both essential in software modeling as they provide a holistic view of the software system. Static models help us understand the structure and organization of the system, while dynamic models help us understand how the system behaves and interacts over time. It's important to note that these models are expressed using graphical languages, such as Unified Modeling Language, UML, which includes shapes, symbols, icons, and arrows to represent the elements and their relationships. These graphical representations make it easier to communicate and understand the complexities of the software system. In conclusion, static models describe the structure of a software system, while dynamic models describe its behavior over time. Both categories of models are crucial in software modeling, and understanding them will help us create accurate, understandable, consistent, and modifiable software models. In the upcoming lessons, we will be exploring these models in more detail. Qualities of software models. The first quality of a good software model is accuracy. A model should be precise and correctly describe the system it is representing. Inaccurate models can lead to misunderstandings and errors in the software development process. Therefore, it's essential to ensure that the model accurately represents the system. The second quality of a good software model is understandability. Models should be as simple as possible and must be easy to communicate. It's important to remember that not everyone involved in the software development process has the same level of technical expertise. Therefore, the model should be easily understood by all stakeholders, including developers, project managers, and end users. The third quality of a good software model is consistency. Different views of the same model must not express things that are in conflict with each other. For example, if a class diagram shows that a class has a certain method, the sequence diagram should also show that the method is being called. Inconsistencies in models can cause confusion and lead to errors in the software development process. The fourth quality of a good software model is modifiability. Models must be easy to change and update as the software development process evolves. Software systems are complex, and changes may need to be made to the model as new requirements or constraints emerge. A good model should be easily modified without compromising accuracy or consistency. In conclusion, a good software model must be accurate, understandable, consistent, and modifiable. These qualities ensure that the model represents the system correctly, is easily understood by all stakeholders, and can be modified as the software development process evolves. See you in the next topic.